Oh, I think the record button is going. I want everybody to look out here at this beautiful reach of stream. Here we are in Oconee County, Georgia, on, what do you know, a rainy Monday for lab. And we're missing y'all being with us out here, and we appreciate y'all watching us over this recording. There's Dr. Jay Shelton, live and in person right there. Here I am. I guess you could see me okay there. And I want to talk to y'all a little bit about today, how to evaluate habitat. And that's something that Dr. Shelton will be doing with us. We're going to be reviewing a list of characteristics of a stream with Dr. Shelton, 10 of those to be exact. And one of the things that we're going to do is bridge what we did a few weeks ago with habitat availability and habitat assessment in the stream with the leaf litter bags. You remember picking those things out of the water. We're going to do that together. But this time, we're going to talk a little bit more about evaluating components of a stream with a score, kind of like we did with the Habitat Suitability Index, the HSI, with gray squirrels and wild turkeys when we did that. Today, we're going to look at 10 components of a stream and give each of those components a score from 1 to 10, so the whole stream could have a total score out of 100, in other words. So we'll be able to grade the stream today. Each of the 10 parts is going to be a separate video that Dr. Shelton will put together for us. And I think you're really going to like this and the ability to do this with your own students, I think, for sure. So with that being said, we're going to jump in literally here out in the rain and do this for you and evaluate this stream.
So we're getting ready to do our stream assessment. This protocol is based on the width of the stream. We will assess a stream reach that is 12 times the stream width. So this stream is approximately 10 steps wide. So we're going to assess a stream reach that is 10 times 12 or 120 steps long. And we will look for the habitat types that occur within that section. Are we ready to begin?
Let's do it.
All right, here we go.
All right. Dr. Shelton's counting, and we're walking along the creek, and we're observing the bank and the creek from this safe distance. If my steps are about 3 feet apart, steps now, not paces, if my steps are about 3 feet, then 120 times 3 is 360, so 360 feet of creek. Pretty cool. And of course it's raining. I know you're surprised. Got our GoPro out here. Just counting along. Look at this. Noticing things about the creek. Notice how Dr. Shelton's kind of hugging the bank there a little bit. He's not walking in a straight line. He's being parallel to the edge of the creek. And there he is.
That's 120 steps.
So 120 steps, or in other words, about 360 feet. We've just observed the bank, and now we're going to go grab our data sheet and talk about each of those 10 characteristics that we're going to do together. So let's do that now.
This data sheet is from the Georgia Adopt a Stream program, and it's a stream habitat survey. And this is what we're going to use today to collect all of our information. The first question is whether this stream is rocky bottom or muddy bottom. And you see we can check that off right here. We've already walked our stream. We've got a good idea of what the habitat types are. And in this case, it is a rocky bottom stream.
Okay.
So we're going to go ahead and check rocky bottom.
Okay.
The next thing we're going to do is rank habitat metric number 1, which is called epifaunal substrate.
Okay.
And we've got everything from a really, really good and excellent stream, which is going to get a score of 10, to a very poor stream, which is going to score of 0.
Okay.
And in our case, what we're looking for are the things that you would expect to be colonized, the areas that you would expect to be colonized by macroinvertebrates and salamanders and fish.
Okay.
And so those would include things like submerged roots, woody and vegetation debris, cobble, and leaf packs and undercut banks.
Okay.
So, and what we're going to do now is look at for examples of those. Are those examples all present and common? Are those examples present but rare? Are those examples absent?
Okay.
And that's how we're going to give it a score.
From 10 to 1, okay?
From 10 to 0. Actually, you could have a 0.
Oh,
Yeah,
okay,
that's
from
right.
0, okay.
All right. So in this case, let's take a look around. And keep in mind now, what we're looking for are the substrate types. You see the big cobble?
Yep.
You see there's actually, within the cobble, there is some gravel, some small gravel. You see that there are trees with the roots reaching right down into the water.
Mm-hmm.
And those undercut banks have roots stabilizing them.
Yeah.
You see that although it's winter and everything hasn't greened out yet, we still do have riparian vegetation, shrubs, and some smaller trees growing along the bank.
Okay.
What you don't see much of is sand, silt, and clay.
Okay.
And those are going to give you a poorer score. Sand, silt, and clay gives you a poorer score. Large woody debris, large rock gives you a higher score. And that's why we're going to be on the high end of the range for this particular metric.
Just like we saw with our habitat suitability, we did with the leaf litter packs, all that CWD in the water was great. And we're seeing a lot of cobble and dead wood and things in there. So that's great. So if we go back over to our sheet, like we're going to do right now, and we're going to give ourselves a score. And Dr. Sultan's going to, what do you think about this one, Doc?
About an 8 or an 8.5. What do you think?
I'd say 8.5. That
8.5.
sounds great.
All right, so
Okay.
we're right in there.
All right.
So we're going to give it an 8.5.
Just going to write it
And then
there.
we can sketch a little bit of our stream. But our sketch, of course, is going to have lots of big rock. It's going to have some woody debris sections in there. It's going to have some shrubs along the bank, and it's going to have some bigger overstory trees growing. So that's why we gave it such a good score.
Excellent. All right, on to the next one.
On to the next one. All right, we're ready to do metric number 2, which is embeddedness. And embeddedness actually means, if you look at all of the larger substrate sizes, how much of that habitat is embedded with silt, sand, and clay. So let me give you an example now. Watch, I'm going to reach down here because we've got this beautiful gravel substrate down here. When I pick that gravel up, you'll see that there is a little bit of sand, silt, and clay, but for the most part, this is good, clean gravel. Good, clean gravel is great substrate. This is really, really important. If this was lacking, then that would give us a poorer score. But if I'm going to step out just 1 or 2 paces farther. You see these nice big cobble-sized rocks?
Yeah.
You'll notice when I pick those rocks up, there's not a big plume of silt. That's very, very good. So we got nice, clean gravel, and that gives this stream a higher score. It has little embeddedness, which is a good thing.
Huh. Okay. And I can just imagine the macroinvertebrates that we identified living underneath of those things, those caddisflies, stoneflies, mayflies. That's great stuff. So let's go back up to where our sheet is, up here under the barn, and give ourselves a score.
All right, here we are. We're going to do embeddedness, which is metric number 2. Now, metric number 2 is only scored for rocky bottom streams, and this definitely is a rocky bottom stream. And we notice that, again, it's the same scale, 10 to 0, where 10 is the highest possible score. When you got a lot of gravel, you got a lot of cobble, and it's only slightly embedded, in other words, very little amounts of sand, silt, and clay, and that gives you a high score.
Okay.
And quite frankly, this is about as good as it gets. I would give this a 9.5. Because while the gravel wasn't completely pure and clean, it was very close. So here, we're going to make our little sketch again.
Okay, down here.
And of course, we got lots of substrate sizes represented here, and my very poor artistic abilities of gravel and cobble and even some big boulders. And we're going to give it a 9.5, which is a very good score.
That's great. And on to number 3. Look at this down here. So I'm going to talk about riffles, runs, and pools. And Dr. Shelton, when I'm looking at a creek like this, what kind of things am I looking for to differentiate between those 3 things? Like, where's a riffle, where's a run, and where's a pool?
All right, so we use our eyes and we use our ears to distinguish between riffles, runs, and pools.
Okay.
And so if you're looking for riffles, think about turbulent water. So the water's not only moving, but it's moving in a turbulent manner, and the turbulence is caused by a sudden elevation drop.
Okay.
And that's what we're looking at right here.
Okay.
So a riffle is, there's another mayfly. A riffle is created by a sudden elevation drop, and it's actually this large substrate. You see there's even some woody debris in there, but this substrate causes the drop. They have the drop there, and this is actually a really important habitat type. We call it the food factory. But the thing about finding a riffle is you just listen for it. And I bet you can hear the sound of this riffle. So noisy water is riffle water.
Okay, so that's a riffle right up there and that. How about a pool?
So let's move down here. And silent, flat water. You can't hear it. And you see that it's not all disturbed on the surface, except that we have some rain falling. And so pools are deeper areas. If we went out here and measured the depth, we would find that it was much deeper here than it was in the riffle. And of course, this is still water, quiet water. Those are areas of deposition. Notice we've got some woody debris in this that is deposited. And if we went down on the bottom, this is where we would find all that leaf litter. In a natural stream, we have all that leaf litter that is settled down on the bottom here, and you already have sampled, and you know that that leaf litter is another important habitat type. So pools with cover, pools with woody debris are the best pools of all.
Wow, of course, with CWD, of course. So now what about a run?
All right.
We saw a riffle, pool, what about a run? Let's run down here.
Runs are intermediate in velocity and intermediate in depth. So you can tell that the water is moving, but it's not making a sound. And with respect to the depth velocity combination, it's in the middle. It's between a pool, which is deep and slow, and a riffle, which is very shallow and very fast, and a run is in the middle. So moving water, but not turbulent flow, laminar flow, and intermediate depth.
Okay,
so
we've got a run, and even beyond that, we've got a riffle.
And this cycle repeats itself over and over again in a healthy stream. Riffle, run, pool, over and over again. That's what a healthy stream has. Ah,
that's cool. And it sounds like the title of a song or something there too. Riffle, run, pull, riffle, run, pull. Now look at this before I let you go and we go back to the handout. All these examples of raccoons coming down here and eating these invasive clam species, shells everywhere. Pretty cool stuff. Onto the sheet.
So we're ready to score metric number 3, which is riffle, run, pool habitat. Is a diversity of in-stream habitats available that includes riffles, runs, and pools. If there are all 3 present and frequent within our stream reach, then it's going to get a very high score. If only 1 or fewer is present, then it's going to get a poor score. Now in our case, we've walked the entire stream reach. We've seen multiple examples of all 3, riffles, runs, and pools. They're all frequent, and we've seen examples of those. And so we know we're going to get a really good score here. If anything is limiting, I would say that it could use more deep pools. It's only got a few pools, and so I'm going to give it a 9.5 here. 9.5.
Okay.
And we'll draw our little sketch here.
Absolutely.
Which again, now this is like a aerial view of our stream, but all we need to indicate here is that we've got riffles, that we've got some runs, and we've got some pools. Riffles, runs, and pools.
Something out of Van Gogh right there, that drawing. There you go. All right, on to number 4. So when we look ahead on our sheet, point bars and islands, it said, Dr. Shelton, talk us through what you're seeing here as good or not so good.
Okay, this is metric number 4, and this is sedimentation. To determine the degree of sedimentation, we need to come to a bend in the river. And that's where we're standing here. We're standing in a bend in the river, and we're standing on what's called the point bar, the inside bend in the river, and the far bank, the opposite bank, is the cut bank. The fast velocity over on that bank creates what's called a cut bank, and over here we have what's called a point bar. So we're evaluating the degree of sediment, and what we're looking for is, are there many examples of unstable point bars or unstable islands in the stream? So we don't see any islands, and by island I mean an accumulation of fine sediment that does not have vegetation on it. And here's an example of a point bar right here. You see this area, it is below the high water mark.
There's
below
that
the high water mark right there.
Okay.
But notice that it is vegetated. So it is stabilized by vegetation. How do you know it's stabilized? Well, it's actually got gravel on it. You see the gravel down there? Unstable point bars and unstable islands will be nothing but pure fine sand, silt, and clay. Because the next time it floods, all that material can get washed away or get moved around. So in our case, we're looking for unstable point bars and unstable islands, and we see very, very little evidence of any of that.
This is a stable one with the bigger pieces of cobble there, and those unstable ones are not a good thing, but the stable ones are good.
Good.
Okay, interesting. Just imagine if you were a turtle. That would be good to get up on. It's stable.
Got some
Good.
vegetation.
So we'll go back to our sheet now. Now that we've looked at the outside and the inside, we'll go back and give it a score here together. Great.
Okay, metric number 4 is sediment deposition. Are point bars and islands present, and are they stable or unstable? And so you can see that a really high score comes when the point bars and islands, if they are present, are all stable and small in size and low in frequency. A very poor score comes when you have lots and lots of point bars and islands and they are all unstable. How do you know if it's unstable? If it's unstable, it will have very fine sediment size. The point bar or island will be large in size, and there will be little or no vegetation. So in our case, we had very little point bar development at all. We saw no evidence of islands. The few point bars that we saw were quite stable. They had gravel, cobble, and they had vegetation.
Yes.
So again, we're going to give this a very high score. I would give it a 9.5. All right, so we're going to make our little map very quickly.
Right.
But you notice that our map is simply not going to have much in way of point bars, and it's going to have no islands. So, good score.
Interesting. Another good one. On to number 5.
All right, metric number 5 is channel flow status. Basically, if you look out at the stream, the question here is, does the water reach the bank, the low bank, on both sides of the stream? And the low bank is defined as the zone where rested vegetation is what it's called. Basically, do you see green stuff growing on both banks, and does the water touch the green on both sides? And in fact, it does.
Okay.
So we do have full flow. The substrate is not exposed and dry, because dry substrate doesn't do any good for fish. And so we're going to get another very high score for this metric.
And even though, just kind of talking about this, we've got a lot of rain, so it's flooded some more. Dr. Schouten, how would we factor that in, that this might be a little bit biased with it being a little full pull? What would you say?
It's probably a little bit higher than it normally would be at base flow. Technically, in a perfect world, we'd come out here in June or July to see what it looks like under base flow.
Okay.
If it looks like this at base flow, it would get a perfect score.
Okay. But something, again, you can easily assess with your students bank to bank on the lower side. Cool. Let's go back to the sheet for number 5.
All right, metric 5, channel flow status. Does the water reach the base of the lower bank on both sides? And is there little substrate exposed? And in this case, that would give you a perfect score. And we're out here, and there has been a little bit of rain for sure, so we're not at low flow. So we're not going to give it a perfect score, but we're going to give it another good score, about a 9.5, because if you look from vegetation on one bank to vegetation on the other bank, we would see that the water pretty much touches both sides. So that's a very good score.
And then we're going to take in a second and total up the score on the first page before we flip the page and do the second side. There we go.
Okay, metric number 6 is channel alteration. So we're looking for evidence of the types of things that humans have done to alter the channel. And those could include dredging. They could include different types of agriculture, straightening of the channel, different types of modification of the shore area.
Like
So
those
in
rocks.
this case, we do definitely see examples of modification. You see all this concrete over here that was stacked here. That's obviously not natural. And if we scroll downstream to the lower end of our stream reach, we see that where this bridge was constructed, we actually put concrete on either side to support that bridge structure. So we're going to get a little bit lower score than we have been giving for this particular metric.
And just imagine what that might do in terms of runoff and things. Yeah, it's holding the bank back, but some of that stuff could just run right down that concrete and right down into the water. So that's, yeah, absolutely good to see. And notice we're not even down in the stream right now. So another pretty easy one to do that you can do with your students. All right, back to the sheet.
All right, we're moving on to metric number 6, which is channel alteration. The question here is the stream channel altered by humans? All right, so what types of human alteration are we looking for? We're looking for straightening of the stream, alterations such as dredging, evidence of dredging, evidence of agricultural activity, concrete banks, or construction activities. And in this case, we're probably not going to get as good of a score because while we don't really see evidence of agriculture, we don't see evidence of dredging, we definitely do see that there are some concrete structures and some construction related modifications to the bank. So here I'm thinking we're going to move down and probably go to about a 7 or a 7.5. It's really not too bad. I'm thinking maybe going to 7.5 here.
Okay. All right.
And in our case,
another picture.
We take our picture, and here what we really got is this gabion or concrete support on some of those very steep banks, and then we've got our bridge, which also has some concrete there.
That's great. And Doc, I'm looking ahead here at number 7, and it's saying to us that this is only for muddy bottom streams, and I thought we said that this one was a rocky bottom stream.
That's right.
Okay.
So because we're doing a rocky bottom stream today, we will not count number 7, but if we had to, what we'd be looking for here is sinuosity. So the number of curves or meanders of bends in the stream, we would actually count how many of those bends there are in our section of stream. But we're not doing that today because that's for muddy bottom streams, not for rocky bottom streams. Whereas you may remember, going back this way, we did number 2, which is embeddedness, which is a metric that we only do for rocky bottom streams, not for muddy bottom streams.
Okay. So actually one of the things, Doc, I mentioned at the top of the whole segment here was that this was a score out of 100, where in fact, it's actually a score out of a total of 90 is our top most perfect stream score. So
because we only count 9 out of 10 total metrics.
That's right. Interesting. All right, let's move on to number 8 then, bank stability.
All right.
Okay, Doc, so I'm looking on this sheet here, number 8, bank stability. And I'm seeing on there that really for the rest of this handout, the other 3 that we have to go, bank stability, vegetative protection, and riparian vegetative zone width all have a left bank and a right bank question that we give a score to. How do you determine what's left and right bank? I mean, doesn't it depend on what direction I'm facing? How do you know?
Well, there is actually a correct answer for that. And the answer is you have to ask the river. So what you have to think about is, which way is the river flowing? So the river's flowing in this direction, and so you face the same downstream, you face the way the river is flowing, and then the river's left is the left bank, and the river's right is the right bank. So we are on the right bank, and the far side is the left bank.
There you go, like stage right, stage left. Let's go down here to the side of the bank, and let's take a look at bank stability together and see how we're going to score that left and right now that we know our left from our right. All right, coming on down here. That might be something to know for the handout. Hint, hint. Okay.
Bank stability.
You got it.
So the question here from our score sheet for bank stability number 8 is, how stable are the banks determined right and left? And so what determines the stable banks versus unstable banks? Well, we're looking for evidence of erosion, scouring, undercutting, or bank failure, which means unstable. We're also looking for evidence of overhanging vegetation, which is also very helpful. So right now what we're going to do is pan out a little bit and take a look, and you'll see that there definitely is vegetation on the banks, even though it's not the same on both sides. So looking downstream, you look downstream, you see that vegetation is better on the far bank, which is river left,
right?
Correct.
River left, correct.
Correct.
Left, right.
Whereas where we're standing, we see that there is more unstable banks, less vegetation, and more unstable And by unstable, you can think of a steep bank is not a good bank,
Okay.
whereas a gradual smooth gradient is more stable.
Okay. On the left side over there and on the right side, we're looking at this. We're going to go back to our table and give a score there on this guy now.
And left is going to get a better score. Right is not going to have as good of a score.
Okay,
In this
good deal.
particular section.
Okay. And I was noticing a little bit up above, but we're going to talk about that, I think, in just a second.
That's right.
Cover above. Okay, let's go to the table.
All right, moving on to number 8, bank stability. How stable are the banks? And that's determined for both the right bank and the left bank individually. And what we're looking for is evidence of erosion, scouring, undercut, and then also how much vegetation is overhanging. Well, both of these scores are going to get bumped a little bit, get nicked a little bit, because we definitely do have some steepness, both on the left bank and on the right bank. And on the right bank, we noticed that there is definitely less overstory vegetation. And so probably on a scale of 0 to 5, we're kind of going down here to, I would say 3.5
Okay.
here for the, I'm sorry, yeah, for the left bank, and then slightly lower on the right bank because the right bank has less overstory vegetation. Left bank's not perfect. We definitely saw some steep banks in some areas where we had to put concrete because the banks were so steep. Left bank, though, doesn't have those trees and overstory vegetation to keep it stable. And so a 3 on the right bank and a 3.5 on the left bank. Okay. Sometimes these two scores, left and right, are extremely different.
Wow, okay.
In this case, they're just slightly different.
And I can see that. And it's nice that this one you've got a little bit more specific with the decimals, and you've got each bank you're going to be scoring. Important for your students to know whether it's left or right. So, Doc, we got a 6.5 total on that one?
6.5 total on that one.
All right, moving on to the vegetation side, number 9.
Moving on to metric number 9, which is vegetative protection. Are stream banks covered and shaded by a variety of vegetation? By a variety of vegetation, we're talking about overstory vegetation, the big mature trees that provide shade and leaf litter. We're talking about the mid-story trees, the smaller trees that you see over here. And then we're talking about the understory vegetation, the ground cover and the smaller green material that you see down on the ground. And of course, we're not at the ideal time of year because we haven't had full leaf out and everything is still in the emerging stage. A little bit later, there'd be more green stuff out here. But you can see that on both banks here, what we're really talking about, again, pointing downstream, the left bank, we do have sparse overstory mature trees. We do have a pretty nice bit of mid-story, understory trees. And then with respect to ground cover, we have a little bit. But when we move over here to the right bank, different story. We've got fewer overstory. We've got fewer understory. And you'll see that the ground cover is not really natural. It's almost mowed right up to the edge. And so that's going to get a poorer score. So again, we're going to get a higher score on the left bank and a little bit lower score on the right bank.
And there's that flow we can see going down. Right bank, left bank. And also, Doc, I'm just kind of thinking out loud. I'm thinking the overhang onto this creek from the overstory and midstory is providing shade, and it's cooling the temperature, which might be better habitat.
Summer, which makes it better. And the other really important thing is what we call the allochthonous inputs. Allochthonous is a limnology term. It basically means the leaf litter and the stems and the twigs and the woody debris. It doesn't originate in the stream, it falls into the stream.
Okay.
So you can think of these trees. I say wood is good. Wood is good for fish because the trees, when the leaf litter and the woody debris falls into the stream, it nourishes the stream.
We talked about FWD, fine woody debris, and CWD, and here it is coming back full circle to us again on left and right. Let's go back to the sheet. Okay, so let's take a look at this, Doc. 9 and 10 as we wrap this up on our sheet. What do we got?
Okay, so we've got metric number 9 is vegetative protection, and that's along the stream bank. So are the stream banks covered and shaded by a variety of vegetation? And again, as we mentioned earlier, that variety needs to be overstory, understory, and ground cover. And you'll see here, in a perfect scenario, we'd have abundant overstory, understory, and ground cover on both banks. But in our case, the left bank was a little bit better, but still we had somewhat sparser vegetation. So I gave it a 4 because it was pretty good. But on this bank, on the river right, on the right bank, we definitely had a lot less overstory vegetation. So a 4 for the left bank, a 3 for the right bank, for a score of 7.
Okay.
And another thing now, as we expand out farther away from the stream, because you remember the term watershed. The watershed is very, very important when you consider stream quality. And if we go out, if we expand outward, what is the riparian vegetation zoned width? And by zone width, what we're talking about is considering an area that is adjacent to the stream but farther out. That's what we call the buffer zone. The buffer is it a large variety of vegetation that extends out at least 3 channel widths on each side. Is it only 2 or maybe 1 channel width on each side with human activities? Or is it little or no buffer with vegetation extending less than 1 channel width and lots of human activities? So here, I think we're kind of in the mid-range. We can definitely, as we scale out and we look around, we're going to see evidence of human activities. Yes, we do still have some vegetation, but it's kind of limited, not as much on the far bank as it is on the near bank. But you see, I gave it a 3 here for the left bank, which has a little bit more vegetation and a little bit less human activity. But on this bank, I gave it a 2.5 because there is quite a bit of evidence of human activity. Hi.
And we're
If
going
you
to
scale around here,
and we're going to walk out and look and just kind of 3 widths, stream bank widths out, which is about 30 feet. So look at it. There's a baseball field over here. Dr. Shelton and I are underneath of a shelter right now, thank goodness.
Got a parking lot?
We got our parking lot out here. So that's an impervious source right there. And then you look over here, there's a playground, there's a dumpster. So this is an area that's not so great in terms of the watershed out there, which is interesting to note. And I think that's why, as Dr. Shelton was saying, that's why those scores are the way they are. Now, if you take a look at this, and we're going to talk in recitation, our total score was 73, which makes it still in the excellent range, but it's on the lower end of the excellent range. So more on that coming up in recitation. Let's kind of do a little reflection on this in just a second, talk about where we're going from here. All right, so we'll do our social distancing right over here. This pole is protecting us from all the bad stuff. But together today, we've been doing this handout with these 10 different features that we looked at. And it's kind of made me a little bit nervous because some of the things you've been saying is, I'm going to give it a 7.5, I'll give it a 9.5, and it just kind of seems like you're winging it a little bit. Does that make you nervous that this is so subjective when we scored the stream?
Well, it doesn't make me nervous because I'm an expert.
That's right. Well, we know that.
I've done thousands of these, but here's what I would answer to that. It's a really good question. We always want to consider how much confidence we have in information. Whether we accumulated that information ourselves, how much confidence do we have in it, but especially when somebody else tells you something, how much confidence do you have in that information? So we've actually done studies. As a part of quality assurance, quality control, I've been trained on how to do these habitat assessments. And a small team of experts, 3 experts, what we found is if 3 experts come out and score the same stream independently, their estimates are going to be very close together. If you're not an expert, if you're a volunteer, you've never done it before. If you take a larger group, say 20 students or 20 teachers, 20 volunteers, and you score the same stream, you'll come up with about the same average, but a larger distribution. So the range will be greater for the novices, the range will be very tight for the experts, but the average will be about the same.
Interesting. And that's why, and you're going to see this on your handout, why we're asking you about where you grew up, because I think that the mindset that someone comes with this, a good stream to you, if you grew up in the mountains of North Georgia near a national forest, it's tough to get to a good stream. Right. But if I grew up in downtown Atlanta and I look at a stream like this might be perfect to me. So So it's all relative. So we kind of have to calibrate ourselves there.
Exactly right.
We'll talk more about that recitation. But thanks for watching this, everybody. Not nearly as fun as having you in person, but hope you enjoyed it, and we'll see you in recitation. Thanks,
Yeah.
Doc. All right.